Hello and thank you for subscribing to Introverse Tech. This is a channel where we explore new trends in technology, including artificial intelligence, machine learning, Python programming, cloud computing, and many other areas. So today we're going to look at a built-in function in Python called zip, and I'm here at the Python website, and if I just go to zip, you can see that it's as they define it, it is able to iterate over several iterables in parallel, and it can produce tuples with an item from each one. And another way to think of zip is that it turns rows into columns and columns into rows, which is very similar to transposing a matrix. Zip is lazy, and the elements don't get processed until the iterable is iterated on, as an example by a for loop or by wrapping in a list. And we're going to look at some examples and to clarify the concepts. But in general, it's a really easy function to use and very, very useful. So ideally, the iterables passed to zip are of the same length. However, it is possible that they could have different lengths, and Python offers different approaches to dealing with this issue. So let's have a look at on this page you can see that some examples are given. So let me go to my Jupyter notebook and let's go through some examples. So the first one we have is that we have list names, and it's got 3 items, and then we have scores, and you can see the items in these are matching. So the format is to say these two iterables, and we are zipping them together and saving the results in a zipped variable, and to print it out we just need to use list before the variable, so it converts that into a list, and then we can print that. So let's run this, and we expect that because the number of items are same, it should print and match them correctly. So as expected, Alice, as an example, Alice got 85, Bob got 90, and Charlie got 88. Now we can also look at where lists have different sizes. So let's take another example, a slightly different one, but everything else is the same. So 3 items in both. Let's run that. You can see that runs correctly, but as an example, let's say we just have, in terms of the prices, we just have 2 items, whereas the number of fruits is 3, and we are trying to iterate, and you can see it's of different lengths. So when we run that, it runs, and by default it just matches both iterables, and it runs out. So you saw that apple matches to 100, pineapple matches to 175, and since water lemon doesn't have a matching item, it is dropped. So that's the default behavior. However, this could result in bugs where we are not able to determine that the lists were not even. So there's a way to highlight this error or bug. So let's take another example. Here we are zipping A, B, and C to 1, 2, and 3, and we're adding a condition called strict equals true. So when we run this, you can see that it runs fine, and it matches A to 1, B to 2, C to 3. Similarly, if we iterate through that using a for loop, and we are choosing range 4, which goes up to 3, so in other words, it's counting to 0, 1, 2, and 3, so 4 items in total, and we are matching them to 4 items here as well, so that works fine, and you have the strict equals true turned on. Now as an example, and you can see the output is matching our understanding. So let's say if I change this to 3, so now it will iterate to 0, 1, 2, so that means 3 items. However, we are trying to match it to 4 in the other iterable. So let's see what kind of message we get. So when we run this, you can see that it immediately throws an error and says that argument 2 is longer than argument 1. So this is a good way to capture this this error or this bug, because it could manifest itself and it could be very hard to find it if it's running as part of another program. So it's good practice to include this to be able to catch this kind of error. Now we can actually zip not only 2 but multiple lists. So here as an example we have 3 different iterables, and they all have, just to make it easier, they all have the same size of items. And when we run that, let me select that, and when we run that, you can see that zip successfully matched each one of those. So this teacher had this grade and it was in the subject, so all of them matched correctly. So you can see the power of zip to be able to convert multiple iterables and convert that into lists, as we can see here. We can also zip strings. So let's say a string has ABC, string 2 has 1, 2, 3, and when we zip them together, we get as expected A to 1, B to 2, and C to 3. Similarly, we can zip dictionaries, and dictionaries are slightly different from lists, but we can still use zip, and by default zip will only zip the dictionary keys. So let's look at the example. So we have dictionary 1, dictionary 2 with Alice age 25, Bob age 30, and following the same syntax. When we run this, we get just the dictionary keys, and we don't get the values. So it's not very useful. So if you want to get values, what we need to do is change this to when we are calling the dictionary key dot with the values, so that it can pick up the values as well. And when we run this, we get the values associated with those dictionary keys. So we saw how it can read lists, it can read strings as well as dictionaries. Now a question could arise: what if we wanted to unzip a certain file? So let's take a look. We have these zipped lists, cities, 3 cities with their respective populations, and when we can zip them, let me just or take away this so it makes it easier to understand. So when we run this, let me just add that here. Let's list it. So it's zipped. Okay, let's run that again. So correctly it matches New York with its population, London with its, and Tokyo with its population. Now we wanted to unzip this file, right? How would we go about doing that? So similarly, we can also unzip a zipped file. So let's have a look. We have cities, populations, and when we zip them, it will combine New York with its population, London with its respective population, and Tokyo with its. And the unzipping format is very simple. You have the zip built-in function, and in brackets you use the variable that contains the zipped data, and just add an asterisk before that. So let's run that and let's see. So you can see that it is unable to unpack the cities and populations that were originally in their own, but when we did the zip, we were able to combine them, and using the zip with the asterisk zipped, it will unpack them. So this was a quick introduction to a very powerful and useful Python built-in function called zip. Hopefully you enjoyed this tutorial and was able to follow along. I look forward to your comments, and we'll be creating more content. Thank you for watching.